5. My name is Granshri Singhal. Starting up with the preliminary questions. First is how does a neighbor is decided in a local search? So local search neighbors are usually decided by randomly choosing different variations or possible options available to us. The values which are assigned to certain variable or the constant which are deciding the factor. So in this specific SLS, we can see that at times the values are chosen to be more random and not in a specific manner, but the values are often decided by how the various values which are assigned to the specific constant. So next up is the difference between random walk and random restart. Random walk is working when it just randomly chooses the neighbor from the same local optimum or the dead end which we are stuck at. So it means that it will just try to find the neighbor which is more close to it, or it is it is attached to the specific area we have reached. And the random restart is how we will try to find a random point in different all the map. We will try to find any different constant, like the the variable that is present to us. So we will try to find the solution from that point. So it means that random restart just starts from a new place with a new slate and new state. So yes, it is kind of like new beginning as compared to random walk. The two weaknesses of the SLS are it reaches the local optima. It is not very good because it doesn't try to find a global optimum solution for all. It is more like a locally optimum solution. And the lack of systematic observation. One thing I notice is that SLS is very random, and it will just try to find a brute force solution without following any specific method for it. Like DFS and BFS follow a specific systematic method for searching. So yeah, as compared to that, it is more unsystematic. Question D is how with the given information, how will I select the variable in the semi SLS, the semi made SLS. So when I tried to form this, when I saw that the constraint on this intersection 1 is that it should be stopped. So I believe that if I just assign the intersection 1 to be stopped, the solution would be way easier to find for the algorithm. So I have chosen greedy descent with two stage, and if I initialize and just select this to be stop, I believe we can see that it is satisfying various things. And when I try to auto solve, it just finds solution in one step because it has found a good option for it. So this solves the problem that if I choose the intersection 1 to be stopped, then it is way easier for the algorithm to find the solution for it. So the next question we have in this is, would uh, the same partial CSP as above will likely find a solution in 100 steps with using only random walks. So I try to construct a plot. First, this statistics, we can see that in this it has a mean and median of 13.77 and 10 respectively, and this means that it has often found the solution very correct in very less number of steps, even though at times it may have used 100 steps, which are the maximum signed one steps, but the most of the times it stayed to be more closer to the 10 and 13 steps. So I will try to show the same example. I will try to run a batch run. I selected 1000 batch run because it gives more flexibility and options and variety, so that we can see that it is not luck that is playing a role in this specific headset. So plot 3, as we can see that again it has tried to use the 100 max step, even though but it has mean and median which is 14.45 and 10, which means that oftentimes it has just found the solution in just 14 or 10 steps. So yeah, it would have been able to find the result in a pretty accurate way, but even though it is not 100% success rate, it still has a very higher chance of success in finding the solution in just 100 steps. So that is all for my lab assignment. Thank you.